Let's do an example. How many carbon atoms in a 1.3 carat diamond? And then it's telling us diamonds are a form of pure carbon, and 1 carat equals 0.20 grams. Well, let's write down the numbers. We've got 1.3 carats, and I'm told that 1 carat equals 0.20 grams. And what am I trying to find? Number of atoms. So we got two different things here that we could potentially start with. I want to start with the one on top because that's just a single unit. This is an equality, and I could use that as a conversion factor. So I could go from carats to grams using this information that they gave me. And from grams, I could do what? I could go to moles, and then from moles to atoms. It's not the only way, but just following what they did in the book. 1.3 carats. Got grams and moles and atoms. Carats, grams, moles, atoms. And then fill the units in the bottom. And make sure that they actually cancel out, and not just that you wish they canceled out. One carat equals 0.20 grams. They gave that to us because that's a weird conversion factor that nobody remembers. So 1 carat, 0.20 grams. How about this moles and grams thing? Where do we get the numbers for that? Periodic table. This is carbon. We need to know that carbon is C, and under C, 1 mole is equal to 12.0108 grams. And then we need the number relating atoms and moles. This is the chemist's dozen. Mole is like the dozen, and atoms is like the eggs. So the number goes with the atoms. And I always forget to leave enough room for that.
And you did the 12.0108 because that's carbon, right?
Because it's carbon. And I was using the periodic table on the wall. What I usually do is, a lot of these I have 4 sig figs memorized, and so I would normally just do 12.01. 1.3 times 0.2 divided by 12.0108 times 6.022 EE23. And how many sig figs should this have? 2. This is our final answer. I'm going to round it right now. 1.3 times 10 to the 22 atoms. That's really, really big. Is it okay that it's that big? So a 1.3 carat diamond, can you see that with your eyes? Yeah, that's a nice sized diamond. That's pretty big. There's got to be a lot of atoms in it, right? So it has to be a big number. Yes?
Does it matter how many significant figures we put for the weights of elements?
That's a good question. Does it matter how many significant figures I put in here? It does and it doesn't. In this calculation, I have this number with 2 sig figs and this number with 2 significant figures. I do not want to have my molar mass limit the number of significant figures. We also don't want to introduce rounding errors. So what I would say is you want to use at least 4 significant figures in your molar mass. So if you want to do 12.01, that's fine. Carbon is really close to 12, and so if you rounded it to 12, it probably wouldn't cause a problem. But things like Chlorine, if you round that to the nearest whole number, that's going to cause a problem. So don't get into the habit of rounding your molar masses to whole numbers. It's not a good idea. I'm going to skip that one because I'm tired.